Welcome aboard, where aviation concepts become simple. From instruments to aerodynamics, we make exam prep clear and cockpit learning faster. This is StudyKwik Aviation.
Welcome to StudyKwik. In this lesson, we will look at the errors which pitot-static air pressure sensing systems are subject to and the corrective measures taken to balance out or reduce these errors. The first error we will look at is called position error. Ideally, the airflow around a pressure head should resemble the smooth flow shown in diagrams. However, when the aircraft is moving, a suction effect is created, which causes the static pressure sense to be lower than the actual ambient pressure. As speed increases, the airflow near the Pitot-Static heads becomes turbulent, and this underreading becomes greater. The amount of error depends on the location of the pressure head and the aircraft's speed. Speed and turbulence may also affect the pitot tube readings, making them either above or below the correct value. At high angles of attack, a component of dynamic pressure may be sensed at the static head. Errors are usually greatest at high angles of attack and low speed. The high angle of attack may also cause a loss of dynamic pressure in the pitot tube. In addition, operation of the flaps or slats can significantly change the angle of attack, which affects turbulence and airflow. Flight manuals may even list different values of position error for different flap settings. Before moving to the next error, let's see how position error can be reduced. One method is to replace the static pressure head with a static vent. Certain points on the aircraft, usually on the fuselage sides, allow true or nearly true static pressure to be sensed across the whole speed range. A static vent is fitted at such a location. A static vent is simply a small flat metal plate with holes forming an opening in the center. It is fitted flush to the fuselage and connected to the pressure lines that feed the instruments. A line from the vent is angled upwards to prevent water accumulation, so heating is not required. By using a static vent, about 90% of the position error can be eliminated. To minimize errors from yaw or side slip, two interconnected static vents are often used, one on each side of the fuselage. This duplication also reduces the chance of blockage. However, static vents are not suitable for every aircraft. On very high-speed aircraft, shock waves at high Mach numbers can cause significant errors if static vents are used. In such cases, a special high-speed pitot-static probe is used instead. These are designed to minimize position error, but are more expensive than the simple combined probes used on slower aircraft. Now let's look at the second error, maneuver-induced error. This error results mainly from temporary fluctuations of air pressure at the static vents. These fluctuations are caused during changes in the aircraft's angle of attack, or when flaps are extended or retracted. Maneuver-induced error is most noticeable during pitch changes, for example, at the start of a climb, leveling off, or descending. The result is a lag in pressure instrument readings. Let's take the vertical speed indicator, VSI, as an example. In level flight, the VSI reads 0. But when the aircraft climbs at 500 feet per minute, the VSI pointer shows plus 500. But when the aircraft levels off, the VSI does not instantly return to 0. Instead, it lags and shows a value that does not represent the true flight path. This is the clearest example of maneuver-induced error. This lag can persist for several seconds, meaning the instruments cannot be relied upon for instantaneous accuracy. At higher altitudes, this error tends to last even longer. Now let's examine the full pitot-static system. A typical system shows that the two pitot systems function independently, and the two static systems also function independently. Although the captain's and first officer's systems are separate, they each sense pressure from both sides of the aircraft. In addition, the static systems can be cross-fed and supplied by an alternate static source if the primary source is blocked. The alternate static source may also be called the emergency static source. However, since it is usually not located at the optimum place on the aircraft, it often provides less accurate readings. In pressurized aircraft, the alternate static source is often placed in the unpressurized rear fuselage. In unpressurized aircraft, it may be located inside the cabin. As a result, the static pressure sensed will be slightly lower due to suction. This causes the altimeter and airspeed indicator to overread. Such errors are usually listed in the aircraft flight manual. Older or basic aircraft transmit pitot-static pressure through pipelines to the instruments. In modern aircraft, the information is transmitted electronically via pressure transducers, improving accuracy. Let's summarize this lesson. Position error is caused by suction and turbulence near the pressure heads. It is worst at high angles of attack and low speed. Static vents reduce this error. They are usually fitted on both sides of the fuselage and interconnected. Maneuver-induced error is caused by rapid pitch changes, leading to lag in instrument readings. Alternate static sources provide backup, but may cause altimeters and ASIs to overread slightly. That's all for this lesson on Pitot-Static system errors. If you found this helpful, don't forget to like, share, comment, and subscribe to StudyKwik.